hope you've been having a great day. Today, we will learn about triangles and its angles. Okay? So, I'll be talking first the basic things about triangles and then we'll move on to the discussion about its angles and some algebra related problems. Right? Let's continue. So, first, let's discuss about the formulas that you have to remember regarding triangles. Alright? So these are the basic things you need to remember whatever triangle is given. There's only one formula to take note when you want to solve for the area. Okay? So it's not that clear. I'm sorry. So the area of any triangle, is actually base times height divided by 2. Okay? So we have here the bottom part. This is the base. Okay? This is always the base. Or this could be the base. The base. But the height differs. Okay? The height is, for a triangle similar to this, it would be from a point down. Should be like complete line. And at times, the one side is slanting. So when you draw the line, it should be straight. Alright, so again, the formula to remember for area of a triangle is base times height divided by 2. There's no problem with perimeter because when we talk about perimeter of any figure, we just add all the side lengths. Okay? So area of a triangle, very simple. Base times height divided by 2. Let's continue. Types of triangles according to side measure. We have actually 3. Okay? So we have equilateral, from the name itself, equal. Okay? Equilateral triangles, I'll not read the discussion, the ones written here, I'll just discuss anyway. So equilateral triangles means all sides are equal in measure. Okay? Sides are equal in measure. And always remember that if it's equilateral triangles, therefore, the angle measure of each angle is 60 degrees. Because the total angle measure, so total angle in any triangle, that this means total angle measure, okay? So this is 180 degrees. Okay, it's always 180 degrees. It's the total measure of the angles. Yeah, let's continue. We have isosceles triangles. So these are triangles that has two sides are equal in measure. Okay, this symbol here means equal. So the two sides are equal and the other side is not. But we say isosceles triangle, no side is equal to any. So meaning to say they all have different side measure. So to be definite with this, we could say equilateral triangle. For example, this is 5 centimeters, therefore this should also be 5 centimeters, and this should also be 5 centimeters, alright? So if we say this is 4 centimeters, therefore this should also be 4 centimeters, and you could put any value here. Then here, we could just make up our any angle, so it could be, you use any number, therefore that would be isosceles, okay? So always remember those things. Alright, let's continue. And then we have things to take note. If you remember the term symmetry, okay, this is just things that you have to take note. When you talk about isosceles triangle, this is a triangle whose no side is equal to each other. Okay, so all side measures are different from each other. It has no line of symmetry, meaning to say, if you put a line from the vertex to the other end, okay, not to another vertex, okay, just make a straight line, it won't give you an equal pair. Because look at an equilateral triangle. Okay, so here, this is like an equilateral triangle. So if you put it that way, it would cut our triangles in 3 different ways, equal in measure. So line of symmetry means, for example, let's just have a simple example. So if, for example, we have a rectangle right here, if I draw a line of symmetry, okay, that means this side should be equal to the other side, right? So these are just side concepts that you can remember, all right? So types of triangles according to angle measure. So earlier was side measure. When we talk about side measure, we have isosceles, isosceles, and equilateral. Alright, so but if we talk about the angle measure, we have acute angled, obtuse angled, and right angled. Okay, from the name itself, if you have learned this before, acute means greater than 0. Okay, greater than 0. So the measure is between 1 degree to 89 degrees, right? Okay, obtuse is more than 90. So it should be 91 degrees to and less than 180. So 179 degrees. Okay, and then a right angle is exactly 90 degrees. This is 1 degree, huh? This is not 7. Okay, let's continue. So here is the definition. Acute angle triangle has all its angles less than 90. Okay, less than 90. So as what I said here, these are the choices you could get. 1 degree to 89 degrees. Right angle is exactly 90 degrees. Obtuse is more than 90, so that's 91, and then less than 180, so 91 to 179 degrees. And remember, I said this earlier, okay? Some of the internal angles, I forgot to say this, internal angles of any triangle is 180 degrees. Okay, so internal angles, for example, here, we say this is angle A, B, and C. So we say that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. And that is true for these two other triangles that we have here. Alright, let's continue. So let's have some few items right here. So if we say that this is 46 degrees, alright, if this is 46 degrees and alright, so if we say that this is 46 degrees, okay, as you can see, there's only one angle given right here because there are properties that we could apply to find the unknown angle. So we want to find the measure of angle A. So we say this is angle A and this is opposite to this side, right? And this is an isosceles triangle. So this is also A. We need to say they're equal in measure. So what we could do, we could just subtract. So we say, right, we say that angle A plus angle A, okay, the measure of angle A plus the measure of another angle A. Wait, let me erase that. Okay, so I'll rewrite it. So we say that the measure of angle A plus the measure of the other angle A plus the measure of the one given, which is 46 degrees, is equal to 180 degrees, right? So we could use x for measure of angle A because we don't know the value. So it could be x plus I should have not written m here. Okay, so we can just write 46 degrees equals to 180, and then this could be 2x plus 46 degrees equals to 180 degrees. Therefore, we can transpose 46 degrees to the other side. So that would be 2x equal to 180 degrees minus 46 degrees. Therefore, it would be 2x equal to 180 minus 46 would give us 134 degrees, right? Okay. And then, so that we can isolate x, we will divide both sides by 2. Therefore, x is equal to 67 degrees. Okay, so we say that this unknown angle is 67 degrees. Alright, we can check that by adding 67 plus 67, okay, 67 plus 67 plus 46, which is equal to 180 degrees. Alright, actually this is algebra, right? I've shown a solution which is algebra. You can use also just subtract 46 first from 180, alright, and then divide it by 2 because you have two angles that are missing and they are equal. Alright? So the same thing that you could do for this angle B. Okay, I'll leave angle B to you. And then angle C, as you can see, they are of different measure because of the symbol. So what type of triangle this one is? Okay, can this be isosceles? No, of course, no. Two sides are equal. Equilateral? Of course, no. But this is clean. So therefore, what we do, we will just add 51. Okay? You can add 51 degrees plus, oh, that looks so big. May I erase that, please? So I'll erase it then. So 51 degrees plus 82 degrees. Add them up first. So we have 133 degrees, right? So after that, you could subtract 180 minus 133 degrees, and the answer is equal to 47 degrees, right? Okay, so the unknown angle right here is 47 degrees. So measure of angle C is equal to 47 degrees. Again, you can check that by adding all sides. 47 plus 51 plus 82 should be equal to 180 degrees. Okay, let's continue. So, alright, let's skip that. And this one is just proving. Alright. So we have another thing that you need to take note. The sum, if I say that the sum of the interior angle, right? I said earlier the angle, if we add angle A, angle B, angle C, it's equal to what? 180 degrees. But the exterior angle sum of any triangle is equal to 360 degrees. Okay, so this angle in blue, green, and the other one, when you add them up, the measure, it should be equal to 360 degrees. And this is the proving to that. I'll not explain it further so that our time won't be taken that much. So we have to continue. So we have here the three angles in a triangle sum up to 180. So here, you can apply the things you've learned in angle pairs. So as you can see, this right here makes a line. And remember, if this one here makes a line, so we would say that this forms 180 degrees. The first thing that you have to find here, because you cannot find angle D right away unless you know what's B. So what you do, you can add 70 plus 70. Of course, we know that. That's 140, right? And then subtract it to 180. So 180 minus 140 degrees. And this should be 40 degrees. Okay? So therefore, this unknown angle here is 40 degrees. Alright? So what should be the angle, measure of angle D? So what we do, we could add this two. So 65 degrees plus 40 degrees would give you 105 degrees. Right? 105 degrees. And then what you do, you subtract 180 because the total measure in a triangle is the internal angle is 180 minus 105 degrees. Therefore, this is equal to 75 degrees. Alright? So let's write it down, 75 degrees. Let's check. What you could do for checking, you could add them up. So this is our answer earlier, and what is the other answer? So you could do 75 plus 40 plus 65 and check whether that is equal to 180. So that's our checking part. So this should be equal to 180 degrees. So the measure of angle D, so you could say therefore, okay, 3 dots means therefore in math. So measure of angle D is equal to 40 degrees and the measure of angle D is equal to 75 degrees. Alright, so that's one example. Okay, so 40 and 75 and we got the same answer. Alright, so we have another figure. It's the same as the one earlier. Right, but same method, so I'll leave it with you. Find the measure of angle B and angle D. Right, so we have another one right here. Okay, so as you can see, these are all simple given. What we do to find the unknown angle here is subtract the sum of these two from 180. So add up 65 plus 57, okay, 65 degrees plus 57 degrees would give you an answer which is 122 degrees. Alright, so 122 degrees. And then subtract that from 180 degrees. So 180 minus 122, okay, is 58 degrees. So therefore, the unknown angle here is 58 degrees. Alright, so you can check them again by adding. So we can do 58 plus 65 plus 57, and then that should sum up to 180. So these things here, I'll leave it with you. This is simple. This means 90 degrees. So just add this 2 and then subtract it from 180. Same thing here. What about here? The unknown angle is an external angle. Alright? So there's like some steps that you should be taking here. So first, you need to find, you cannot find this angle right away, but there's a clue to this. So you use this using linear pair. So what you do, you subtract 180 minus 137. So 180 minus 137 would give you a sum of 43 degrees, correct? So if this is 43 degrees, what should be this angle right here? So use the property for internal angles. So 43, you could do 43 degrees plus 102 degrees would give you 145 degrees, right? Okay, this is 145, not 143, okay? And then to find this unknown angle right here, you could do 180 degrees minus 145 degrees. And then you would have 180 minus 145 is 35 degrees, of course. Alright, so if there's some items that you're confused with, you can pause for a moment and then you could think, or if you don't understand it still, you can comment down below and I'll try to answer as fast as I could. So therefore, this unknown angle here is 35 degrees. So if you're still unsure of what you got and you want to check whether it's correct, you can add this all up. 102, 43, and 35. It sums up to 180, so most probably you will be correct. Okay? Alright, and let's continue. So what should be the angle here? What should be this measure right here? Should be this measure. So what we do, we use the property for linear pairs again. So we say that the unknown angle, so this is, let's name it using letters so it's easier. Alright, so we can say this is the x earlier. So x, we already found the measure of x, which is 43 degrees. So you could use letters so that it's easier. So this is y. So this is y earlier. 35 degrees. And then now let's find z. Okay, so to find z, you just subtract 180 degrees and then 35 degrees. Okay, so 180 minus 35. Alright, so you get 145 degrees. Okay, so that's just the measure of our angle z. Okay, so I'll use red so that it's the same. So this is 145 degrees. Therefore, you can say therefore, missing angle measure or unknown angle measure. Unknown angle measure. Okay, so unknown angle is 145 degrees. Alright, so that's it. So let's continue. Okay. Okay, let's have an application of vertical angles. So if this is 20, this is 30, what should be this angle? Right? As you can see, we cannot find that angle right away. We need to find this angle here. So to find this angle, you would do 30 plus 20, that's 50, right? And then subtract that from 180. So you would say 180 minus 50. Again, I got the 50 from 30 and 20, the sum. And then the answer here is 130 degrees, correct? So if this is 130 degrees, okay, if this is 130 degrees, angle pair, they are opposite and they are called vertical angles. If they are vertical angles, therefore they should be equal. 130 degrees. If you're still confused with angle pairs, you can look back from the other video that I uploaded. Alright, it's about angle pairs and it's discussing complementary, supplementary, linear pair, and vertical angles. And those are one of the most important things you need to know when you're dealing with any angle measure. Alright, so again, these are the things you need to remember. I'll leave this one with you, so I hope you can answer that. So those are the things that we have to take note for triangles. Bye-bye. Thank you for watching. Hope you learned and reviewed any concept. Please comment down below whenever you have any question. Don't forget to like, subscribe, and hit the bell button for any notifications.